In the dark expanse of space, two types of ancient travelers roam: asteroids and comets. At a glance, they seem similar: small celestial bodies orbiting the Sun, relics from the solar system's formation. But the truth is, their differences run deep, and understanding them unlocks secrets about our cosmic origins. Let's begin with the basics. Asteroids are mostly composed of rock and metal. They tend to orbit the Sun in relatively circular paths, mostly confined to the asteroid belt between Mars and Jupiter. They formed in the warmer inner solar system, where volatile materials like ice and gas were burned off, leaving behind heavier elements. Comets, on the other hand, are icy bodies composed of frozen gases, dust, and rock. They originate from the high cold, distant regions of the solar system, the Kuiper Belt and Oort cloud. These areas are so far from the Sun that water, carbon dioxide, methane, and ammonia all exist in solid form. When a comet approaches the Sun, heat causes its ice to sublimate, turning directly from solid to gas. This creates the comet's iconic glowing coma and a trailing tail, which can stretch for millions of kilometers and always points away from the Sun due to the solar wind. Asteroids don't have tails. They're dry, airless, and relatively inert. But that doesn't mean they're boring. In fact, asteroids and comets may have once shared common ancestors. Some comets lose their volatiles after many close passes by the Sun, becoming darker and more asteroid-like. Conversely, some asteroids have been found to contain small amounts of ice or even exhibit weak outgassing, blurring the line between the two. Take more Comet 67P Churyumov-Gerasimenko, famously visited by the Rosetta spacecraft. This peanut-shaped object is a time capsule of icy material that hasn't changed much in billions of years. Studying its chemistry revealed complex organic molecules, including amino acids, adding evidence to the theory that comets may have helped seed life on early Earth. On the asteroid side, missions like OSIRIS-REx and Hayabusa 2 returned samples from asteroids Bennu and Ryugu, respectively, both containing organic compounds and water-bearing minerals. So while their origins differ, both types of objects have stories to tell about the building blocks of life. Here's another key difference. Orbits. Asteroids generally have shorter, more stable orbits that lie near the ecliptic plane. Comets, especially those from the Oort cloud, can have extremely elongated and inclined orbits, often bringing them into the inner solar system after millennia of isolation. This means that comets can be less predictable and potentially more hazardous if perturbed by gravitational interactions. Their long periods and dimness make them harder to track until they're already racing inward at tens of thousands of kilometers per hour. In terms of threats, both pose risks. The impact energy of either body can be catastrophic. However, because comets move faster and are often larger, their impact potential is even more devastating. Thankfully, such events are rare, but not impossible. One of the best-known impact candidates in history may have involved a comet fragment, the Tunguska event of 1908. Though no crater was ever found, the explosion flattened over 2,000 square kilometers of Siberian forest. Some theories suggest a small comet or icy asteroid disintegrated in the atmosphere, releasing the energy equivalent of a nuclear bomb. So, why does the distinction between asteroids and comets matter? Because it tells us where these objects come from, what they're made of, and how they might evolve. It shapes our strategies for planetary defense, scientific exploration, and even resource utilization. Asteroids may be better candidates for mining due to their stability and proximity. Comets, while harder to reach, offer clues about the outer solar system, solar wind, and even prebiotic chemistry. And then there's the emotional power of a comet, blazing through the night sky, captivating humanity since ancient times. Many cultures saw comets as omens, messengers, or divine signs. Today, we know they are none of those things, but in a way, they are messengers, bringing us news from the furthest reaches of the sun's domain. At Infinity Beyond, we see asteroids and comets not as rivals, but as complementary chapters in the same story. One dry and rocky, the other icy and dramatic, but both crucial to understanding the solar system's formation, evolution, and future. As space missions become more ambitious, we'll explore more of both. NASA's Comet Interceptor, for instance, will wait in deep space for a never-before-seen comet to pass by, ready to study it up close. It may reveal things we've never imagined, because when it comes to these ancient travelers, there's always more than meets the eye. Stay curious, stay watching, and stay with Infinity Beyond.